Good afternoon. In the previous video, we have seen how the stator punching of a single phase induction motor is designed, and we have solved the problem on that. Now in this video here, as we know that the induction motor has two windings, one is a main winding, another one is an auxiliary winding. So here we are going to design the main stator winding. When it comes to an induction motor main winding, there are three types. One is a concentric, second is progressive, and third one is a skin type. When it comes to a concentric type of winding is a non-overlapping type of a winding. And in this here, the number of slots on the armature will be equals to the number of poles here. Next is a progressive type of a winding. Here the starting end of the one loop or the winding is connected to the first commutator here, and the ending end will be connected to the another commutator segment here. That is called as a progressive type of the winding. When it comes to a skin type of a winding here, so winding will be wounded in the terms of a wool style, that is called as a skin. But out of these three, the most commonly used is a concentric type of the winding here. Now next, in the main winding, first we need to calculate the pitch factor here, calculation of the pitch factor here. So pitch factor is, that is the Kp is given by EMF generated in the short pitch coil to the EMF generated in the full pitch coil. EMF generated in the short pitch coil in the sense, if both the coils are not lying under the same pole, then it is called as a short pitch coil. That is, the coil will be, one coil will be less, one coil will be under the north pole, and the coil will be less than and the coil will be not lying under the pole here. That is short pitch coil. If both the coils are lying under both the poles, then it is called as a full pitch coil here. So that is Kp. That is EMF generated in the short pitch coil to the EMF generated in the full pitch coil here. So now, when it comes to an arrangement of winding in a pole group here. So arrangement of winding in a pole group, if we do have 11 windings here, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 here. If you do have 11 windings here, the 11 coils here, so in that how many number of slots you will be having? So between these two, one slot here, 2, 3, 4, 5, 6, 7, 8, 9 and 10 here. So here what I have written, coil 1, that is if we do have a windings 11, then how many number of slots we do have? That is a 10 slot. Coil 2, 2 to 10, in between that how many do we do have? We do have 8 slots. Similar manner here, in between 3 to 9 we do have 6 slots, and between 5 to 7 we do have 2 slots here. So now pitch factor for the coil 1, that is Kp1. So Kp1 is calculated as sine of span divided by total coil here. Span is nothing but slot. Kp1, that is coil 1. Coil 1 में कितने slots है? 10 slots. So write down here 10. And how many number of total coils we do have? Total we do have 11 here. So write down 11 here. Into 90 degree is equal to Kp1 की value कितनी आई? That is 0.9 here. Similar manner we need to calculate the Kp2 here. Kp2 is equal to sine of span. How many number of span we do have? Here 8. 8 divided by total coil, how many we do have? 11 into 90 degree, that is Kp2. Kp3 will be 6. Total coils will be 11 into 90 degree. Now Kp4 will be how much? Kp4 will be 2 divided by 11 into 90 degree. That is C. 2 divided by 11 into 90 degree, that is 0.3. So here we got Kp1, Kp2, Kp3, Kp4, Kp5. Now we are adding all the 5 Kps here. If we add all the 5 Kps, total Kp, how much we are getting? Total Kp we are getting as a 3.1 here. Okay. So next, calculation of a percentage turns. Next we need to calculate the total number of turns in the main winding. Okay. So now if you want to calculate the total number of turns in the main winding, that is T1 is equal to Kp1. So what is the value of Kp1 we do have? We do have a Kp1 value is a 0.9 here. So Kp1 0.9 divided by total Kp. Total Kp in the sense Kp1, Kp2, Kp3, Kp4 and Kp5. That is adding all the 5 Kps, we are getting a 3.1 into 100. That is total number of turns. How much we are getting? We are 30 turns we are getting. Now next T2 is equal to Kp2. Kp2 की वैल्यू कितनी है? 0.8. टोटल Kp कितना है? 3.1. So write down 3.1 into 100. So T2 turns कितने हैं? 27%. Same as it is T3. Kp3 divided by total Kp which is 3.1 into 100. तो T3 टर्न्स कितना हो गया यहाँ पे? 18% हो गया. सो T4 इस तरह से ही हमें कैलकुलेट करना है. Kp4 डिवाइडेड बाय टोटल Kp, वो 15% आया. सेम एज इट इज वी हैव कैलकुलेटेड दी T5. सो दैट इज T1. इफ वी ऐड T1 प्लस T2, T3, T4 एंड T5, so if we add all those turns, how many turns totally we have to get? We have to get 100% here. Okay, next calculation of the winding factor. Okay, so calculation of winding factor, that is Kwm here. So Kw is a winding factor. M is, that is for the main winding we are calculating here. So Kp1 वो अभी हमने find out किया, turns भी हमें find out किया. So Kp1 into T1 plus Kp2 into T2 plus Kp3 into T3, Kp4 into T4 plus Kp5 into T5 divided by total number of turns we do have T1, T2, T3, T4 and T5 number of turns here. That is the winding factor here. Next, number of turns here. So number of turns to calculate, this is the general formula which we are knowing, that is E is equal to 4.44 F5 Kwm into Tm here. So Tm is a number of turns in the main winding, number of turns in the मेन वाइंडिंग Kwm अभी इस फॉर्मूला से मिल जाएगा. फ्लक्स पर पोल फ्रीक्वेंसी हमें पता होती है 4.44 and the EMF induced here. So with this we are getting what? We are getting the number of turns here. Next formula is a conductor size, that will continue in the next video.